And here's 5.5 part 2, another short video for you. Bases other than e and applications. So the integral of e to the x dx we already know is e to the x plus c. So let's extend that to the integral of a to the x, where a is some number. Excuse me, some number. The integral of a to the x dx is 1 over the natural log of a times a to the x plus c. So if a were e, then we'd have 1 over the natural log of e. Natural log of e is 1, 1 over 1 is 1. So this formula is a more generic formula, and this is the more specific one, but this one's easier, so we started with that one. Here's the integral of a to the u du, 1 over natural log of a, and then times a to the u, as long as you've got your du here, and then plus c. So let's use those to do a couple examples. We've got the integral of 4 to the x, so that's just 1 over natural log of 4 times 4 to the x plus c, because it already matches the formula. So I would write that as 4 to the x over natural log of 4 plus c. But what if the exponent is more than just x? Then you have to choose your u as the exponent, take the derivative of u. So it's like doing a u substitution, you just follow the same steps. Solve for dx, and then substitute. So we've got the integral of 4 to the u, and then times dx, which is negative du. Pull that negative out in front, and then we have, that's a bad integral sign. Negative integral of 4 to the u du. Now it matches the formula, so we can just write 1 over natural log of 4 times 4 to the u plus c. So negative 4, back substituting, u is negative x over natural log of 4 plus c. Okay, what about this? It looks like it's a product. Here's our product. We could pull the 5 out, but we'd still have x times 3 to the x squared. But we do have a base to a power, so we know this is going to be an exponential situation. So we could pull the 5 out, and we'll have x times 3 to the x squared over times dx. Choose u as x squared. Take the derivative of u. It's 2x. Multiply both sides by dx, divide by 2x. So solving for dx, you get du over 2x. So let's substitute. We have 5 times the integral of x times 3 to the u times dx, which is du over 2x. So our x's cancel. We have another constant now we can pull out. So 5 on the top, and then this 2 in the denominator comes out as a 1/2. So we have 5 halves out in front, times the integral of 3 to the u du. Now this matches our rule. So our answer, or the integral of 3 to the u du, is 1 over natural log of 3 times 3 to the u plus c. And then simplifying and back substituting, we've got 5 times 3 to the x squared over 2 times natural log of 3 plus c. You cannot multiply these two together because they have different exponents, and you always have to do powers before you multiply unless they have the same exponent. You can't multiply these together. If you want, you could write this as natural log of 3 squared, but otherwise there's nothing really that you can do to simplify this. You know, you could put that 2 up there and make that 3 squared, natural log of 9 if you want, but nothing else cancels, so that's your final answer. Definite integrals, pretty easy, just 1 over natural log of 3 times 3 to the x, and then from negative 1 to 2. So plugging in, we have 1 over natural log of 3 times 3 squared minus 3 to the negative 1. So that's 9 minus 1/3. You could leave it like that or simplify it or whatever. 27/3, 26/3. There's your exact answer. Alrighty. Just a reminder of some compound interest formulas that you've learned in pre-calculus. Let P equal the amount of the deposit, so that's this initial deposit right here. T is the number of years, so that's that years right there. A is the balance after T years, so that's how much money you're going to end up with. R is the annual interest rate, so that's going to go there or there. And make sure you change that interest rate to decimal form, so if it's 5%, you're going to use 0.05. And then N is the number of compoundings per year. So if it's compounded like 12 times per year monthly, you'd put a 12 here and a 12 here. If it's compounded continuously, there's no place to put N because it's not compounding number of time, N number of times per year. So the formula for compounding continuously is PERT, P times E to the RT. And that's what you need for those formulas. Here's your homework.